Hey everyone, I'm Michael, a developer community manager for the Hubs team, and today we're going to be talking about Community Edition, and more specifically, I'm going to be walking you through the steps I've outlined in this quick start guide on using Community Edition on Google Cloud with some AWS services. Now, Community Edition just launched this week, October 16th. We've laid out a lot of the details about why we've chosen to move to Community Edition from Hubs Cloud. I highly recommend you check out this article I have on my screen here. But as part of that announcement, we released this step-by-step guide, which gives you some great introduction to Kubernetes, which is the technology that Community Edition runs on. Zach Fox did a wonderful job outlining some introductory material to containerized software. If you look about halfway down under the deployment prerequisites heading, this is where the actual step-by-step guide begins. And so we're going to be walking through that today. I do want to give a quick disclaimer that this guide is just one way of hosting Community Edition. You could host it in many different ways on Google Cloud with different services. You could choose to host on AWS, on Azure, on DigitalOcean, basically any platform that supports Kubernetes. You could choose to host it on a local device or a server in your closet. So while this captures a step-by-step process, it is in no way the definitive way of hosting Community Edition. All right, so for this guide, we're going to be using Google Cloud to host our Kubernetes cluster and AWS for our DNS and SMTP services. The first prerequisite for this guide is to make sure that we have an account set up on both Google Cloud and AWS with billing enabled so that when we create these resources, we can pay for them as we go. So I have set up my Google Cloud account, and I also have my AWS account ready. I've linked out some tutorials on how to get started if you haven't already set up an account, but for this tutorial video, we're going to skip over the account creation process. All right, so for part 2 of our prerequisites, we'll be using 2 third-party applications to do a couple of things throughout the tutorial. The first is VS Code, which is a code editor which we'll be using to fill out pieces of the Community Edition code before deploying with our chosen services. And the second is the Lens IDE, which allows us to peek into different parts of our Kubernetes cluster once it's running to verify that it's working correctly. Once you've downloaded, and you can get a free version of each of these, but once you've downloaded, this is what the VS Code application will look like, and this is what the Lens application will look like. So for part 3 of our deployment prerequisites, we'll be downloading a few pieces of software that we'll use throughout the tutorial. I do want to pause here and say that I am running all of this on a 2021 M1 MacBook Pro, and I think I'm using the macOS 13.1. Some of this software you might need to download a different version, or for something like Homebrew, a different kind of package manager altogether. I've included the ones that work specifically for my computer here. So the first is Homebrew, which we'll be using to download other pieces of software. We'll need the Google Cloud SDK to run a lot of the creation commands for our Kubernetes cluster. We'll need kubectl, which is kind of the standard way that you can run commands for Kubernetes. And lastly, we'll need gettext, which is for a very specific line of the Community Edition code, but in testing, we found that we actually needed to install this beforehand. All right, so that covers our deployment prerequisites. Now for step 1 of actually getting started, we'll need to configure our DNS on AWS's Route 53. So in the AWS console, we're going to pull up Route 53. For anyone that's set up a Hubs Cloud instance in the past using a domain on Route 53, the process looks very familiar to that process. You may even have an existing domain on Route 53 that you would like to reuse for your Community Edition instance. In the guide, I've put together some of the steps if you need to register a domain for the first time that you can follow to do so, but we'll be working with an existing domain, so we won't go through those steps in this tutorial. Great, now once I have my domain registered, I'm going to be going into the Hosted Zones tab on the left-hand toolbar to create some records for my domain. I'm going to click that tab, And if my domain is correctly registered, I should be able to select that to create those records. Now, when we create these 4 A records, we'll be giving them placeholder values, which we'll come back and edit later in the tutorial. For each of those, we'll click Create Record, and then we'll fill out some information here. Now in the guide, we can see the first one, we'll just keep the subdomain blank. We'll want to make sure that A is specified for the record type, and then for the placeholder value, we'll just do the IP address of 0000. Create that record. Then we'll repeat for the second record. This one will be at assets as the subdomain, A record, and then same with the placeholder value. Just going to repeat this for the next one, which is stream, A record 0000. And lastly, we'll do it for cores. Right. And we'll click Create a Record. Fantastic. Now, once we reach this point, we've correctly configured our domain for pre-deployment. Once again, we'll be coming back later to expose those specific subdomains to the IP of our Kubernetes cluster later on. Great, so for the next step of our deployment, we'll be configuring our SMTP service using AWS's SES, or Simple Email Service. That looks like this in our AWS console. And first we'll be going to SMTP settings in the left-hand toolbar. Next, we're going to make sure we mark down this SMTP endpoint, which we'll be putting into our code. I'm going to copy it, or I'll come back later to grab it. But the big thing is we need to configure a credential which will allow our Kubernetes cluster to send emails through SES. And to do so, we're going to be clicking this Create SMTP Credentials button up in the top right. So I'll select that and it will redirect me to the IAM section of AWS. Now, we can customize our username if we want to. I'm not going to, it's optional. We'll want to make sure that we see these 3 values, which will allow us to send the emails that we need to for hubs. And then we're going to click Create User. Once we're past this point, we'll have a username and password. I will have blurred mine out, so you probably can't see it since these are sensitive credentials. But you'll want to copy the SMTP username and SMTP password, which you'll pass through to your Kubernetes cluster once you configure it. So I'm going to mark these down and click Return to Console, and then we'll have our SMTP service set up for pre-deployment. One last thing on SMTP before we move on, and specifically within AWS, I'm currently using a SMTP account that is still in sandbox mode. Now, if you've set up Hubs Cloud, you'll be familiar with the process of getting out of the SES sandbox, but just for this quick start, we're going to be staying in the sandbox. However, it is one of those things you should consider to make your Community Edition instance production ready later on. All right, so now we're on to step 3, where we'll be actually creating our Kubernetes cluster on Google Cloud, which will later receive our deployment spec for Community Edition. Now, I do want to say here, depending on how you've set up your account, the default size of your Kubernetes cluster may vary, which can impact how much money it costs to run your Community Edition instance and how many users your instance can support by default. If you're interested in learning more, there are a ton of different flags you can use to specify different settings for your Kubernetes cluster. We'll be keeping it pretty simple, but I highly recommend you dive deeper into this, especially as you consider how to make your Community Edition instance production ready. But we'll be keeping it pretty simple with the defaults here. And for this section, I'm going to be doing it all in the command line. So first we'll need to make sure our Google Cloud SDK is connected to Google Cloud. So I'm going to type gcloud auth login. We'll open up a separate tab. Let me show that here. It's opened up a tab in my web browser. I'm going to allow it to connect, and then I'll click allow. So it has confirmed that I have logged in to my account. Great. Next, we're going to make sure that we're in the correct project that we want. So as you can see, when you set up an account, you might not have projects configured, and I've linked out to a few steps that you can take to configure your project. But for now, I'm going to type gcloud config list to confirm the project that I want to use, and I am in the project that I want to be using for this tutorial. Great. Next, we'll be actually creating our Kubernetes cluster on Google Cloud with this command. And here's where you'll begin to specify some important parameters. So the command is gcloud container clusters create. And then we'll want to give our cluster a namespace. For this, I'm going to type Hubs Cloud Community Edition -MHM, those are my initials, -tutorial. Next, we'll want to specify our zone by typing --zone equals and then our desired zone. And for zones, we generally recommend having your instance placed wherever you expect most of your user base. For today, I'm going to be using the zone that's closest to me, but you can look more into zones here. And for me, that zone is US-South1-A. Great, now when we run this command, it's actually going to begin creating a cluster. I'm going to run it, and it might take a few minutes for this to take place. You can see a message that the cluster is being configured, and so we'll come back here once that creation process is completed. All right, coming back after a few minutes, we can see that our cluster has finished creating and that it has outputted some important information about the cluster that was created, including its IP, confirming that its namespace looks correct. You can see information about the number of nodes that were created, the machine type, which is going to be tied quite closely to the amount of money that you're paying each month and the number of users you might have coming in. So it's good to just look at all this information to get some general information about your cluster. All right, now we're on to step 4, where we're going to be editing the Community Edition code with our chosen services and then deploying that configuration spec to our Kubernetes cluster. So we have a link to the GitHub, and we'll be using VS Code as the editor here. I've set up a tutorial video directory, which I'll change into real quick, that we'll be using. So we'll be doing it in this directory here. Now looking at the Hubs Cloud repo, the first thing we're going to do is simply clone the repo into our VS Code. So we're going to run git clone, then the URL for the repo. We'll see that we have the Community Edition folder in there. Let's go ahead and also change into the Community Edition directory. Okay, so now I'm in the Community Edition directory. So let's take a quick peek at what's in there. We have a README, we have 2 .yam files, and then we have 2 bash scripts in here. And the one we're going to be concerned with for this step is the render_HCCE, which stands for Hubs Cloud Community Edition.sh. If we look in here, we have some required parameters that we need to update ourselves based on the services like DNS and SMTP that we've created. And then we also have some other code here. The big takeaway from this script is that it will take all of those configurations and edit the hcce.yam file and then turn that into a .yaml file, which it will then deploy as the deployment spec to our Kubernetes cluster. So let's begin to update those required parameters. I've listed all of the ones that are absolutely necessary in this document. So the first one is our hub domain. And this is the domain that we have specified in Route 53 of AWS. And for me, that's devmoran.com. Next, we have the admin email. Now, we haven't specified this anywhere, but this is basically the email that is applied as the first administrator to your hub. And it's very important to specify an email that you have access to so that you can sign in and begin adding other people via the admin panel to your hub. So for me, I'll just use my Mozilla email. Great, the next is our namespace, and this is the namespace that we specified when we created our cluster. For me, that's hcce-mhm-tutorial, so I'll update that here. Now let's look at this next set of parameters, which are all related to the Postgres database that we're specifying. Now, for this quick start, we aren't going to be editing any of these, but it's very important to consider editing these for more security reasons, especially our password and our username for our database. So we'll skip over these for now. Next, we'll enter those important credentials that we got from our SMTP service. So if you remember, the SMTP server was that endpoint URL that we have right here. So I'll copy and paste that. Next, we have our port. Now, this might vary depending on the service you're using, but you can see on SES that we have a few here, and I'm going to be using 25, but there are a few that we could technically use. So I'm going to specify port 25. And then we have our username and password, which we got when we created that IAM credential. So I'll be blurring these out, but I'll copy and paste those in here now. Next, we have a few passwords that we need to specify ourselves. Since this is a quick start, I'm just going to use a random password generator, but this is another one of those points where you should really consider doing something that's a little bit more production ready when you're ready to move on to that phase. So I'm just going to be looking up a random password generator. Lastly, we have our Sketchfab API keys and our Tenor API keys. Now, Sketchfab is a 3D model database, and if you're familiar with hubs, in World you're able to search for specific models that you can then drag and drop or upload to a specific scene. Tenor is for animated GIFs, which is another in-world feature where you can call that API to upload a GIF to your scene. But for this time, we're just going to keep them as question marks. Go ahead and leave the values as question marks if you're not interested in configuring those here. All right, so now we should be ready to run the command which will deploy our configuration spec to our Kubernetes cluster that we configured in the previous step of this process. Now, I do want to note here that while you run these scripts, there might be some changes that you have to troubleshoot depending on your device and your operating system and your operating system's version here. During testing, for instance, we added in this little check here to make it more accessible to more platforms, but just be aware as you're deploying, you might have to troubleshoot that step a little bit. But I'm going to clear my port here, make it a little bit bigger, not that big. And I'll grab the command here from the tutorial. Okay, this is going to run render Hubs Cloud Community Edition.sh, and then with the YAML file that it outputs, it's going to apply that using kubectl to our Google Cloud instance. So I'm going to run that. Since we can see in line 52, there is a sudo command to install an npm package. That's why it's asking for my password, so I'll just enter that here. Great, and that will continue. We'll see on the left-hand side there's a new hcce.yaml file, and we're seeing that a lot of services and deployments have been created, and then it returns successfully. Great, now we have applied our deployment spec to our Kubernetes cluster. Just using the command line, we'll want to verify that deployment. So we're going to say kubectl get deployment, and then our namespace. So type mine in. Oh, no deployments found. Why is that? Oh, I forgot to specify the -n namespace selector. So kubectl get deployment -n, and then the name of the namespace for our cluster. Awesome, okay. So we see Great, so we can see that all of the services have been uploaded. It looks like Reticulum might not be ready yet. That could be because we've only just deployed. Let's rerun here. Okay, so now it is ready to go. Reticulum usually takes a little bit longer to get up and ready. So all of our services are up and ready, and I've included an optional command here if you want to look into each of those individual pods. Awesome, now we're on to step 5. We've deployed our Community Edition spec to the existing Kubernetes cluster, and now we want to expose that cluster's IP to our domain records that we configured in Route 53 at the beginning of this tutorial. So we'll get our IP address using this command and then go back into the AWS panel to apply those to our records. So the command is kubectl. We'll want to specify our namespace. And then we're going to type get svc, which is get service, and then lb. Great, and here we can see our external IP there, which is the important one that we'll want to copy. Great, going back to AWS, I'm going to navigate back to Route 53, to the Hosted Zones tab in the left-hand toolbar. I'm going to select my domain, and then we'll go back through those 4 A records to update that placeholder IP address with the actual external IP of our cluster. So I'm going to select edit record for each of these and just paste over in the value section with that external IP. I'll click save and then move on to the next one, to assets. Then I'll do it for cores. And finally, I'll do it for stream. Great. And then we'll give it a few minutes to propagate, and then we'll attempt to connect to our hub for the first time. All right, so now that we have exposed our external IP address to our domain, we can actually try and connect to our hub for the first time and start using it. Now, I've already done a little bit of testing in the background, but if you're joining your domain for the first time on a fresh deployment, you may have to self-sign some of the certificates in order to access your URL. Usually, your browser will give you a warning or say that it's an unsecured site, and then give you an option to go ahead and proceed. But I'm going to go ahead and test going straight to my domain, and I can see here that I'm at the home page when I connect to devmoran.com. Now, I think the first thing we should do is try signing in with the email we specified as admin to make sure that we can connect to the admin panel and that our SMTP service is working correctly. But before doing so, I want to take a peek into the backend using the Lens IDE to get a little bit more information. So if I click the Lens IDE on setup, it should automatically detect any clusters that you have access to on Google Cloud. And inside of here, I'm going to click the Workloads tab and the Pods tab. I can see a list of the pods that I have running. Everything looks good. Now I want to look into the logs for Reticulum. And in Lens, I can do this by clicking on the Reticulum pod and then clicking the logs, the pod logs button, which is that third icon in the details. Oh, I think I'm actually blocking it with my screen. It's this pod logs button up here. And then I'll get this pop-up at the bottom of my screen where I can see some of the traffic and processes happening on here. And I'm going to use this to test our SMTP service. Now, going back to my web browser, I think you might have trouble seeing it here. I'm going to try and sign in, and then I'm going to enter that admin email that I specified in my deployment spec. So for me, that was my Mozilla address. Mistyped. And if I send and go back to my Reticulum logs, here we can see if that email send is successful, I'll see a WebSocket connection, and I should see no errors here. And I did receive an email. I can see I have it down here. And I'll open it up in a separate tab to sign into my hub for the first time. Great. Back here now I can access the admin panel, which is fantastic. And I can go ahead and begin connecting to Spoke to make scenes as well. Wonderful. Now, one of the last useful debugging tips I want to share is how to verify your configuration values. I'm going to do this by clicking on my reticulum pod and then clicking the pod shell button, which is right next to the pod logs button. This is going to allow me to SSH into that pod. And then if I want to check the file that I've uploaded and the values in there, I'm going to look into the config.toml file by typing cat config.toml. And if I look up in here, I can find all of those values that I specified in the hcce.yaml file. Awesome. The last tip I want to share as we're verifying our deployment is how you can reapply your deployment spec with new values and have those new values take effect in your cluster. Now, at any time, you can run render hcce.sh to reapply that template, but it won't take effect by default. You'll have to terminate your existing pods and let them respawn. Now, the great thing about Kubernetes is when you terminate a pod, a new one will be respawned, and after applying a new deployment spec, that new pod will have those new configurations. So I'll just demonstrate that process for Reticulum in Lens. I'll go over here and delete the pod. We'll see that it's beginning to terminate and that another one automatically respawned. It's going to take a little bit of time to get back up and running, but the good news is that new pod is going to contain any updates that I've made using the deployment script. Great. Now, as the last step of this case study, we're going to be configuring our certificates so that we don't have to get that warning and self-sign each time we want to connect to our hub. And if we look in the GitHub, we can see that we can either bring our own certificates using certificates that you might register on AWS or some free service, or you can use Hubs' free certbot bot, which is a service and makes up that cbb.sh file that you see in Community Edition. So for this tutorial, we're going to stick with the certbot bot, but it's good to know that you can also bring and configure your own certificates. So to set up our certificates using this service, we're going to go back to our VS Code. We're going to go into the cbb.sh, and we can see at the very top there are a few things that we need to fill out. First, we need to fill out our namespace, then our admin email, and our hub domain. This is all information that you can basically copy over from the render hubs cloud community edition.sh. So our namespace, I'm going to enter the same admin email address, and finally our domain. All right, now once we have configured those parameters, we can basically just run this script for it to be applied as a service to our hub. So I'm going to type bash and then cbb.sh, and this should run the script and apply that for us. All right, it's been a couple of minutes, but as you can see, we've made it past the first certificate issuing for our base URL. Next, it's going to ask us to continue through all of our subdomains as well. You can see down here, there's assets.devmoran.com as well. During this process, if you're interested in looking, you can always go back to the pod section and go to the certbot bot pod, which should have been created during this process. And you can always open up the logs to see the process taking place. You can see here if a certificate is not detected, it's going to wait 30 seconds and then go through the process of issuing a new certificate. All right, and after I've stepped through all of those 4 subdomains as certbot is issuing them, I can now connect to my instance without any of those SSL issues. All right, so that concludes this quick start tutorial in how to get an instance of Community Edition running on Google Cloud with services from AWS, namely that DNS and SMTP service. Now, I do want to highlight a few considerations that developers should take when considering how to make their instance production ready. The first is scalability. So we've created this on one cluster without too many predefined configurations for vertical or horizontal scaling. The instance we created is scoped for about 15 users, and obviously many of you might have much bigger applications for your hub. The second recommendation is to get out of that SES sandbox, which I think has a limit of about 200 emails. The process is exactly the same as Hubs Cloud. You need to open a ticket, and it will usually take 72 hours, and you have to give them details about how your SES service is going to be used and that it won't be used for any spam or marketing reasons. The next is a big one for anyone who's interested in deploying custom code. By default, Community Edition instances will track with the latest image of the Hubs codebase that we release. We use GitHub Actions to deploy to a Docker image, and if we look into our hcce.yaml file and then look at image, we can see that there are several endpoints for the different pods for those Docker images. This one's the one for Reticulum. We can also see one for Postgres. We can see one for PG Bouncer, Hubs, Spoke. So by default, these will track with the latest versions of the Hubs code, and there isn't right now an equivalent of npm run deploy that Hubs Cloud users are familiar with using to just swap out the file for any of these individual apps. And lastly, anyone who's coming from Hubs Cloud should consider migrating their data. Now, there aren't any official tools released yet, but we're planning to develop and document some processes for how to get existing data on a Hubs Cloud instance and to automatically transfer it over to an instance of Hubs Community Edition. So stay tuned for those processes. All right, so that concludes this tutorial. If you have questions or suggestions, I highly recommend you open issues in our GitHub repo or connect with us on our Discord server in the #Community Edition thread. Thanks so much for watching.